in more details on how SR-IOV gets implemented here on example of Intel Ethernet controller from 710 family is the adapter itself has number of supporting functionalities. So there is virtual Ethernet port aggregator, there is virtual Ethernet bridge, and there are then physical functions and virtual functions. Number of supported virtual functions per device is 128, and then appropriately either over virtual switch or connected with SR-IOV, we will have appropriate number of VMs connected. Logical equivalent is if we are doing SR-IOV in containers, and there we have virtual station interfaces connected to those virtual functions. If we look at how network traffic would be flowing when using virtual function direct assignment to the virtual machines, we will have examples starting with on the same host. So for east-west, we can get using 40 gig adapters. Because of the PCI limitations, we cannot get on dual port adapters to 2 times that much, but let's say that we get to 44 gigabit per second, and the numbers will of course vary per packet size, but this way we can then inside the adapter until we reach the bandwidth limits, we can get this thing through the virtual Ethernet bridge. When we do more of that, it is eating into the same aggregate bandwidth, so the numbers get smaller when we are starting to chain more functions there, and eventually as we continue chaining those functions, the numbers get further smaller because the aggregate needs to stay the same. And when we have like 6 virtual functions utilized, and between them we are only sending, in this case instead of 40 something, we are sending 6 point something gigabit per second. When we start also combining this thing with traffic leaving the server, then from, in this example here, we have 1 physical and 4 virtual functions used. There is the transmit is used for only for the default traffic of netperf, and the VMs are talking between themselves, for example, with 11 gig, but then the external traffic going out is then also 11 gig. And the rate of this external traffic by design of the adapter can be limited by using low-level tools like given here in the example. And here it's important to note that while the adapter itself in firmware has a lot of functionality, we also need to look at how well supported this firmware is, and can we get this type of adapters from what is the normal adoption channel, where normally communication service providers would be buying from the hardware OEMs and telco equipment manufacturers. What is available in this type of firmware there? What is supported in drivers that are being used for different environments? And then also very important is to have the whole stack fully managed and automated. What is supported in the desired software-defined networking solution? So beyond just pure functionality of the adapter, it's important to look at the whole stack, because only then we can fully automate it.